Imagine being able to hit the pause button on life itself and wake up in a future where death is no longer the end of the journey. That's the core promise of cryonics, freezing bodies with the hope of future revival. Welcome to our deep dive into one of the most fascinating and controversial topics in futuristic technology, cryonics. Now, before we get started, don't forget to subscribe to our channel and hit the notification bell so you won't miss any of our upcoming explorations into ground-breaking technologies. Cryonics is a process where the body of a legally deceased person is preserved at extremely low temperatures with the aspiration that advances in future science and technology may one day restore them to life. This concept taps into our deepest desires to defy death and experience the future firsthand. So, how does it work and what makes it scientifically feasible or not? First, let's talk about the biological and technical side of cryonics. The process typically begins immediately after a person is pronounced legally dead. Think of the 5-minute window as the golden period where the preservation starts. Medical professionals then work to cool the body down as quickly as possible to just above the freezing point. This is crucial to reduce metabolic rates and delay tissue deterioration. Imagine putting leftovers in your freezer to keep them from spoiling. The same basic principle applies here, but on a far more sophisticated level. Next, the blood is replaced with a cryoprotectant, a sort of anti-freeze for the human body. This substance helps to prevent ice crystals from forming within cells, which would otherwise cause them to burst and result in irreversible damage. Picture this as filling your car's radiator with antifreeze to prevent it from freezing in winter. The body is then cooled to a chilling -196 degrees Celsius, the temperature of liquid nitrogen. At this point, the body is in a state of suspended animation, kept in a specialized container designed to maintain these incredibly low temperatures. Now, let's delve into the biological theories and promising advancements in the field. Central to these theories is the idea of neuropreservation, essentially preserving the brain so it can potentially be uploaded to a computer or revived in some other form. A leading figure in this field is Robert Ettinger, often referred to as the father of cryonics, who suggested that future technologies like nanotechnology and artificial intelligence could potentially repair any cellular damage caused during the cryopreservation process. This brings us to the fascinating concept of molecular nanotechnology. Imagine tiny robots, billions of times smaller than a grain of sand, repairing tissues at the cellular level. These nanobots could theoretically remove ice crystals, fix damaged cells, and even eradicate diseases that caused the individual to die in the first place. The potential here is nothing short of revolutionary. But the journey of cryonics doesn't end here. There are numerous ethical and philosophical questions surrounding the practice. For instance, if a person is revived in the future who decides their legal and social status, what if the technology to revive them never materializes? This brings us into the domain of speculative fiction but poses real-world ethical questions about identity and continuity of self. Notably, one of the earliest and most famous cryonics cases is that of James Bedford, who was cryopreserved in 1967 and remains in cryonic suspension today. His case offers both a historical perspective and a glimpse into the ongoing commitment and challenges faced by cryonics organizations. Another intriguing example is the story of Ted Williams, the famous baseball player, whose head was cryopreserved separately from his body, igniting public interest and controversy alike. So, what's happening on the legal front? Cryonics is still a largely unregulated field, with policies varying from one country to another. In the United States, for example, cryonics is often treated as an extension of the funeral industry, subject to state regulation. This legal ambiguity raises questions about consent, ownership of biological materials, and the rights of individuals under cryonic preservation. Now, you might wonder, is there any concrete scientific evidence supporting the feasibility of revival after cryopreservation? The answer is not straightforward. While there have been promising advances in the field of cryobiology, particularly in the preservation of single cells and small tissues, reviving a whole human body remains a monumental challenge. Scientists have successfully thawed and revived small organisms like certain worms and even some fish species. but the complexity of human tissues, especially the brain, presents far greater challenges. A significant hurdle is the formation of ice crystals during freezing and thawing, which can cause irreparable damage to tissue. This is where vitrification, a process that turns biological tissues into a glass-like state without forming ice, comes into play. Vitrification has shown promising results in preserving organs for transplantation, sparking hope that the same technique could one day be applied to whole-body cryopreservation. One compelling case is that of the rabbit kidney, which was vitrified, stored, and successfully transplanted, functioning normally thereafter. This experiment demonstrates that complex organs can survive cryopreservation and function post-thawing, suggesting that whole-body preservation might not be entirely out of reach. Let's also explore the societal impacts and potential future scenarios of cryonics. If cryonics becomes mainstream, what implications does it hold for societal structures, economies, and resource management? Imagine a world where people live for centuries, accumulating knowledge and wealth, but also facing unprecedented challenges in population growth, resource allocation, and social dynamics. Such a scenario could radically alter our understanding of human life, mortality, and what it means to be human. On a more immediate level, the cost of cryonics is a significant barrier to its accessibility. Currently, the price for whole-body preservation can range from several tens of thousands to hundreds of thousands of dollars, placing it out of reach for most people. Some advocates argue that as technology advances and economies of scale come into play, the cost will decrease, making cryonics more accessible to a broader population. But we can't discuss cryonics without addressing the skepticism and criticisms it faces. Many in the medical and scientific communities remain unconvinced of its viability, often citing the lack of empirical evidence and the numerous technical challenges that need to be overcome. Critics argue that resources might be better spent on improving our current medical systems and extending human lifespan through more conventional means. Despite these criticisms, organizations like the Alcor Life Extension Foundation and the Cryonics Institute continue to push the boundaries of what's possible, investing in research and development to refine cryopreservation techniques and make the dream of future revival a reality. Let's not forget the psychological and emotional aspects of choosing cryonics. For individuals and families, the decision to undergo cryopreservation can be deeply personal and often fraught with mixed emotion. The hope of future revival can be a comforting thought, but it also brings questions about the nature of existence, the continuity of consciousness, and the possible disconnection from one's current social and familial ties. As we move forward, it's essential to keep an open mind while critically evaluating the scientific, ethical, and philosophical dimensions of cryonics. The pursuit of extending human life and defying death has been a part of our collective imagination for centuries, and cryonics is one of the many frontiers where this dream meets reality. In conclusion, cryonics stands at the fascinating intersection of technology, biology, and philosophy, offering a tantalizing glimpse into a future where death might not be the final frontier. As we continue to explore and push the boundaries of what's possible, who knows what the future holds? Will cryonics deliver on its promise, or will it remain a distant dream? Only time will tell. So, what do you think about cryonics? Could it be the key to eternal life or just a high-tech fantasy? Let us know your thoughts in the comments below. Don't forget to subscribe to our channel and hit the notification bell so you never miss an update on these groundbreaking technologies. If you enjoyed this video, give it a thumbs up and share it with anyone you think would find it intriguing. Thanks for watching, and until next time, stay curious,